So this is the second part of the electromagnetism that I'm going to talk about. If you haven't watched the first one on the motor effect, you may want to do that. Just a quick reminder, the motor effect, right, is using, basically it's using electricity, the current running through the wire, to produce motion, right? It's all about the movement of wires and things like that. Electromagnetic induction is doing the opposite. It is using motion to produce electricity, all right? So you can either use electricity to produce motion, or you can use motion to produce electricity. They're both within this electromagnetic kind of umbrella. All right, and so the idea is that you use electromagnetic induction, excuse me, if you want to create a current or a voltage within an electric system. All right, so this is how generators work. It's how something called a dynamo works on a bike. I don't know if any of you have that. A bicycle where the lights on it will light up as long as you're pedaling, like as long as the wheel is moving. I don't know if you have that or not. But anyway, if you do, then you know what I'm talking about. If not, don't worry about it. But the idea is that you can induce a voltage in a circuit with a changing magnetic field. And it's the same idea as the motor effect, all right, but we just talk about it as something. And so the most common way to do this is in generators, okay? It works. So for example, you could do it, not very helpfully, but here, you can do it even with this. If you have a magnet, okay, and you have a coil of wire, a solenoid, right, this is a solenoid here, and you take that magnet and you run it in and out, if you have a sensitive enough ammeter, you will actually be able to measure the current that is happening. And the faster you move it, then of course, the bigger the current that will be generated. So, or the bigger the voltage that will be induced, all right? So this is what generators do, all right? Let me try to draw a generator for you. Lord help us all. So the idea is that if I have a coil of wire here, yes, that's a wire, okay, and I have a magnet, I was going to try to draw it three-dimensional. I'm not going to do that, but anyway, okay, and let's say this is attached to an axle, all right, and so for example, hydroelectric or steam power or anything like that, the idea is that this is going to be attached to a turbine. Yep, that's my turbine. I'm going to label it. So for example, on a hydroelectric, the water flowing by would cause this to spin, right? Or the heat from steam in a coal or power plant, or a coal or oil power plant, or even in a hydroelectric, or not hydroelectric, sorry, geothermal, or any of the energy resources that we talked about, most of those involve a spinning of a turbine, okay? And so the idea is that when they spin the turbine, then you are also going to spin the magnet. And that spinning magnet, because it has the north and the south pole, well then this is a changing magnetic field. And as long as you put the coil within the range of the magnetic field, then that is going to induce a voltage in that coil of wire. All right, and then so as long as your circuit is complete, then you will start to get a current running through that. All right, now how can you increase the size of the induced voltage? Three ways, and they should sound very similar to what we were talking about earlier. One is that you spin the magnet faster, or you move it faster. All right, you move the magnet faster, you use a stronger magnet, you increase the magnetic field, or the last one, you put more coils in this wire. Sorry, so these are the way you increase the voltage. All right, you move the magnet faster, you increase the magnetic field, or you insert more coils. Okay, so that's electromagnetic induction as opposed to the motor force, the motor effect, but both of them go under the idea of electromagnetism.